Hello everyone, welcome to the tutorial on Velociraptor. I didn't know anything about Velociraptor until 3 minutes ago. I just knew it had an awesome name. But on reading it, I'm like, this is awesome. I'm going to try and actually do it myself at the back. Hopefully there won't be any venue issues I have to deal with, so I can actually have some fun. So please welcome Mike Cohen, who's going to be showing you all about Velociraptor. Mike.
Thank you. All right, thanks a lot. So yeah, I just wanted to have a bit of a kind of hands-on tutorial today, and you can play along and follow along and try it out. If you want to follow along with the slides, you can just jump on. If you just Google Velociraptor GitHub, then you can see our GitHub page, and from there there's a link to the documentation site. And then if you click the documentation link, there's a lot of information here about a lot more than what we are going to be able to cover today. But the presentations, you'll see the Linux.conf presentation, and the PDF, is going to be there so you can follow along. What I'm going to try and do is kind of demonstrate and then see if you guys can follow along, and we'll have to. There's actually a lot of material, so we'll just kind of like work through it, and hopefully it'll be kind of interesting. We'll have a bit of fun. I'm going to try and use this cloud instance, and depending on the connectivity, like the internet might not work too well, but we'll see how we go. So basically, it's more or less a new cloud instance. So we're going to install it from scratch. All right, so basically, what is Velociraptor? So Velociraptor is an endpoint visibility tool, and that means that it gives you visibility into your endpoints. So you can imagine that if you're in an enterprise setting and you have a bunch of endpoints, and endpoints could be servers, could be laptops, could be cloud instances, could be desktop machines, could be laptops, any of those kind of things, then as an administrator, you actually have very little visibility of what's going on. A lot of the time, the machine is off the corporate LAN. It might be in the Starbucks, it might be at home. You actually don't really see a lot of them. They only come in when they get hacked or they have to be rebuilt or whatever. So you don't really have a lot of visibility generally. So Velociraptor is really all about giving you as an administrator visibility to the endpoints, and it actually has an open architecture that allows you to be very flexible in the way that you can collect data from the endpoint, telemetry and state information. And particularly, it's useful for incident response and forensics, where you basically need to go and have a look at a machine that may be compromised, except that the user is on holidays, and the machine is not in the office, so it is not available. So you need to do it remotely, and you want to be able to automate that. So you want to be able to collect this information from thousands of machines at the same time, because you're looking for a particular attribute. So this is kind of the idea. Velociraptor is for hunting, for searching machines for evidence of compromise. So a little bit about me. That's me. I think that's enough. All right. So what will you need today? So as I said, we're going to be installing Velociraptor on our machine or VM or wherever you guys want to do that. So you might want to download the actual release. So we can click on that. Should have opened it in a new tab. Yep. So if we open this in a new tab, and the latest one is 038, so it has a lot of the new Linux features that we're going to be talking about. And you can see that it actually is available in lots of different platforms. It's available for Darwin, which is OS X, Linux, Windows, both 32 bits and 64 bits, and in source code. So what we're going to do today is get the Linux version. So what I'm going to do is just copy link address, and I've just got an SSH session here to my cloud VM, and I'm just going to wget it. So it's it's pretty easy. And now Velociraptor has a bunch of different tools. It has a client, it has a server, it has a configuration builder, and all this sort of stuff. But all of the tools are running from the same binary. So it's just one binary that does everything. And that's what we're going to be using today. And so really, it's not a package. It's just a bare binary. And it has all the functionality in it. So you just download it, change mode +X, and there you have it, right? You can just go help, and it has a bunch of different commands to do different things. And so this is really all we are going to need to do today. So let me just go over here. Okay, so what is it that makes Velociraptor interesting? So we have a client and a server. The endpoints is what we call the clients, right? Which are the desktops or laptops or servers or VM instances. Then we can collect monitoring and response on endpoints, and we can manage the server. But the thing that makes Velociraptor really special is that Velociraptor has a query language. And you might have heard about SQL as a query language, and it's an easy way of actually querying the database. So instead of actually having a database, we have VQL, which is the Velociraptor Query Language, has plugins. And plugins are just sources of data. And so imagine that you are able to send a query to your endpoints, and the query can be anything you want, pretty flexible, and you can query all different sources of data from your endpoints. And that is actually the key to the flexibility of the tool. And we will see as we go along, I'm going to point out some of the VQL statements and some of the features that we are able to do. And you can see how that is actually just implemented by different VQL statements. So that's the root of the flexibility. That's the reason for it. And it's also very easy to deploy. We're going to deploy it today in about 5 seconds. Because it's all just the same binary, it just works, right? So there's no libraries, even in Windows, there's no DLLs or anything. It's just the same binary. OK, so this is just an overview of just to give us a big picture of what's actually happening here. And today, the exercise is going to be like on your local machine. But in reality, you typically have several thousand clients. To give you an idea, maybe 5,000, 10,000 clients in your corporate network. And you have a server, which we call the front end. And the front end is that component that actually is talking to the clients, right? So there's an encrypted communication, send, receive channel, and so forth. And that allows us to maintain communications with the endpoints. Then we have a GUI, and an analyst is going to use the GUI to actually collect the right sort of artifacts, the information. We have a data store and a file store. The other interesting thing about Velociraptor is that it doesn't really try to do any analysis. We don't really have a model of what a user is or a security of what a machine is, or we don't really try and build a model. We just collect data. So really, literally, all it does is you run your query, you get back the result set, and you drop it to disk. Right? That's really all it is. And everything else is built on top of that. So Velociraptor itself is very simple. And because of that, it's very fast and very scalable. And as I'll point out later, as you can see, that everything is just files. And so it's really easy to manipulate them with standard tools like grep and JQ and things like that. All right. So yeah, hopefully, you guys have downloaded this by now. And this is the just change mode +X. All right. So the first step is to actually configure Velociraptor. So Velociraptor uses configuration to be able to create secure communications between the endpoints and the server. And obviously, you'll need different keys for each user, and you have to set it up somehow. So the first thing that we have to do is set up create a configuration file. And there is like a small wizard kind of thing that helps you to create a configuration file. There's a number of different configuration scenarios, and that this wizard is going to help with. I'll make it a little bit bigger, if you guys can see. All right, so config generate -i. -i means interactive, so we're going to basically bring out a little bit of a wizard. And so it basically says, okay, you know, what type of installation do you want to use? The first type is use self-signed SSL, which is what we're going to do today. It's just a very simple demonstration. Obviously, it's not great because it's self-signed SSL, but it's quite sufficient for demonstrational purposes. The second option is to automatically provision certificates. Then it uses Let's Encrypt to sign them. There's a little bit more configuration required there. And this is the one we always do in practice, is authenticate with the Google SSO as well as create certificates and all that. But we're not going to cover that today because it requires a little bit more setting up from the cloud side as well. So we're just going to do self-signed SSL. And you can see it generates some keys. And it's going to listen on a port. Because it's self-signed SSL, you can pick any port you want, let's say 8,000. And for now, we're just going to do localhost. You could just do it locally, browse your local machine. But if you had deployed it on a different machine, you would use this DNS name. You can also use an IP address here, but it's not recommended because then it's harder to change. And we'll just do temp. That's fine. And then it's asking us for a GUI username. And I'm just going to, that's the initial username that will be created. You can also add users later. And we just accept the defaults here. So if we have a look at what it's actually done, it's created two files, server.config.yaml and client.config.yaml. And that is really just all the configuration you need for running Velociraptor. We can take a look at it so that we can get a feel of, you know, what does it look like. It's just a YAML file, and it's divided into different sections. So the client one is actually just the client part of this. So the server one is really everything. So I'm just going to go over that. The server URL is basically, you know, where the clients are going to connect to, which URL they're going to connect to. So it needs to be publicly accessible. And then we have some CA certificates. The CA certificate is used to pin all the certificates. We have some nonces. We have where we're going to install it in Etsy, right? And so on. It's different for the different OSs. We have a local buffer. So here, for instance, we can decide where we could put that. I would put it in / oops. Bye. Like maybe in /temp, Velociraptor buffer. So this is basically a ring buffer that it uses for if it's offline and it needs to send results, it just queues it up in this file. So then it sends it up when it's online again. And there's a number of different things here. It's perfectly fine to kind of modify them after the fact. Yeah. So just to give you an idea what it looks like. So this is great. And so that's cool. We've seen this. We've configured it. We created an initial user for the UI, and it created the two files. So let's test it and see that it works. Okay. And what we can do is manually bring up the front end by hand. Right? So if we can do that, we can specify the config with the -- config flag. And then we just do front end. And I always do a -v because it's just a bit more verbose. In this particular case, I want to see what it's doing. Oh, sudo. Yeah. Okay. And so you can see that it's basically because it's the verbose version, it tells us, you know, a couple of things about what's sort of going on. All right. So it's basically said, yep, I've brought the front end up on TLS. This is the address. you know, the GUI is listening on. So the GUI is not the same as the front end, right? Because we can actually separate them in this mode. So the GUI is where the UI will connect to. And you'll notice that the GUI is only listening on 127.0.0.1 because it's self-signed SSL, so it's a bit more secure if by default it listens just on the loopback, you know, and we can usually SSH in to be able to do that, to be able to actually talk to it. And then you can see that it started out with a whole bunch of services, and then it's ready to go. So because I actually am using a remote instance, what I'm going to have to do is forward my ports. So I'm going to do this -L. You may not need to do that if you're doing it on your own machine. Workshop.velocity. Okay, so this is just a simple SSH port forward. So now I can use my browser to connect to port 8889. I'll bring up a browser first. HTTPS. Okay, and then my browser is telling me, oh my God, you know, it's not a good certificate because we're doing this self-signed SSL mode. When we actually, with the other mode, when we use Let's Encrypt to create the certificates, then it's going to be fine. And you don't actually have to do anything with the Let's Encrypt. You have to set up DNS names and have everything working, and then it basically does its own thing. So Velociraptor will talk to Let's Encrypt and renew the certificate and do its own thing. You don't have to really worry about it. And then you can see that it brings out the authentication. And by default, we have this, you know, basic authentication with just username and passwords. But you've seen that third option. We can use the Google SSO for real deployments, and that's what we normally do. But in this mode, this is OK as well. And it will create that first user that we specified. How many people are following along? Okay, cool. Is everyone all right? Did you get up? Did everyone bring it up correctly? Yeah? Cool. Is there any questions or, yeah, problems? Yeah. So 127.0.0.8889. Yeah, so this is where it's telling us, if you recall, when we started it up, it said the front end is listening on 0.0.0.8000. And remember, the front end is the thing that talks to the clients. And then the GUI is listening on 127.0.0.1 port 88. That's the default. And you can go into config file and change it and all this sort of stuff. But yeah. So yeah, as a by the way, when you use Let's Encrypt, then it has to use port 443, because Let's Encrypt doesn't allow you to create a certificate for, you know, a different port. So in that case, it just does the right thing and selects those ports. But yes.
It actually does now.
Oh, does it?
You can create certificates for web servers which don't run on port 443.
For web servers?
So basically, you have to bring up a web server using one of the tools that it does the test with, or you have to use DNS.
Right, you have to do a text record, right? Yeah, we use the HTTP protocol. So when we do it in the cloud, we need to open port 80 and 443 because the verification happens on port 80, and then it does the thing. Because it's just a lot easier to do that than to do text records. I'm sorry? So it was, you remember when you did the config-i, and it asks you for credentials here. GUI, it asks you for credentials here. Yeah, yeah. So that is the initial credentials. You can always create new ones, actually, I'll just show you how to do that. It's very easy. So you basically velociraptor --config, so server, and then user adds, Bob, for example, and then it says, what's Bob's password, and you just do that, but you have to be sudo. Yeah, okay, and it just does it. So. So this is really good. So it works. I just wanted to bring out the UI so that we could see it and make sure that it more or less works. And I'll go into the UI a little bit more detail later. But this is okay. But like usually you don't run services like this by hand, right? So it's not great. We want to actually deploy it, with a proper service that comes up with systemd and all this kind of stuff. So this is just a test, right? So Control-C out of that. And what we actually really want to do now is create Debian packages for deploying properly. And because this is the Linux workshop, we're going to do Linux clients and Linux servers. And I'm not going to talk about how to deploy the Windows ones. But most of the time, we do Windows clients. But anyway, so same sort of thing, config. We specify the config. Now, what this does is it creates a new Debian package, and it puts the config file in it. So Debian server, okay? And that will create a deb package with the config file in the package, and it's all ready to go. So normally, when we do a cloud deploy and we create our config file, then we will create the deb file, we'll send it off and push it out and just install it on the instance, right? So I'm just going to show you. Oh, actually, let me just. And if you do Debian server, creates the server package, and Debian client creates the client package, right? So there's two of them. Yep. So you can see there's the two deb packages here, the server and the client. But in this workshop, we're just going to install them like together because we're going to talk locally over loopback. So sudo dpackage server. Yeah, so you can use Alien to convert it. As long as it uses systemd, it will just work. I've done it with Alien. But if you want to have a new command in there to say, Fedora server or whatever, RPM server, or yeah, we accept PRs, yeah, and I will also install the client as well, so there'll be, something to talk to, right? So we have client and server, but they're all on the same machine right now. But imagine they could be on multiple, like thousands of clients. And so now we can try this again. We hit refresh, and hopefully it should, come back up and work together. So yeah. And I actually ran it before, so that's why I have, some telemetry data here. But you guys might need to wait a little bit to get telemetry. So this is the dashboard, the main sort of screen. And it just tells you the service status. And typically when we do a rollout, we want to see, like, what usually we do, we deploy the server, right? And then we get the client deb and also MSI, because we typically do Windows. And then we give it to the admin of, like, the customer admin, and we say, okay, you guys push it out with group policy or SCCM or whatever, Puppet, whatever, right? So then they do that. And so we look at the dashboard, and we can then see the rollout happening and the number of clients increasing, right? So the moment is going to be 1, but, like, we look at it and we say, 2,000, 3,000, 4,000. Like, we get a, an up-to-date view. And you can see down here that they've actually asked me to show them all the authorized users. That said the users that we created accounts for. It's just in a table. So, and then the other thing, that this dashboard is all done with VQL, right? So it's just queries. They're just queries, and you write them in. So you can customize them and add other stuff in there. And usually what I do is I usually add the name of the customer, like company X, on the dashboard, because we run so many different deployments that I just forget which one's which. So I do that. That helps me understand. Okay. Yeah. So you can see that that's the dashboard. Let me just go back to the slides to see what I was supposed to cover. Yeah. So we covered the TLS stuff, right? So this is just what's highlighted. So this is telling us where to connect to. This is the front end. We started it up. And then we connected to localhost 8889, certificate error, and then we got the dashboard. Right, so it's actually ready to go. It's all good. Then we created the packages, server and client packages. And then you see there's the debs. And then we install them with dpackage. Yeah, yeah, absolutely. Yeah, so you can do it in debug mode as well, right? Let me just sudo service stop. Velociraptor client. Oh no, it's the other way around. Stop. So this is just systemd, right? So it's the same thing, right? But the client, it uses the client config, right? And then you just do a client-v, right? And then it's, but of course, it wants to write there. But yeah, so you can see it's talking to the server. It's actually kind of interesting to see because it starts, so this is the client ID. It will start up with a particular ID. It's sort of a self-registering system, right? So each client starts up, it looks for keys, for its own keys, and then it says, oh, I don't have any keys, so it generates keys, and that creates its ID in the system, and then it just kind of enrolls itself, and off we go. So you don't really need to provision them in advance or anything. They just start up. And the other thing is this message, because we are in self-signed mode, so it knows, and the config tells it, you are now in self-signed mode, and it pins the certificate of the server. So even though it's self-signed, it's actually more secure because it doesn't rely on a CA now. It's completely pinned, so it's actually even better. And then you can see some obfuscated queries coming in. And then you can see it starting some query executions. We're gonna look at those later. All right. Yeah, so this is how, so you can, I can just leave that on because it will be kind of interesting to see it as we go along. This is just debugging messages so you can see what's going on. Yeah, so the dashboard. So we can see how many clients are connected and the current CPU load and footprint on the server. It's actually pretty low generally. And you can see that right now, it's like 60 meg or so, and it's not doing anything. And typically, we would run like, let's say, 3,000 clients, and the CPU would be like maybe 300 megs. The memory footprint would be about 300 megs, and like 10% CPU, something like that. It's pretty low when it's not doing anything, like idle, and it's scalable, right? So we can actually perform hunts for many machines, thousands of machines, and it's fine. Yeah, so here it's showing us, the number of machines that's gone up to 1, right? And then, but this is kind of what it sort of looks like on a real deployment. It sort of goes up and down, because people tend to go home at night and turn the machines off, and then come home in the morning. So there's some variation, but servers tend to be all the time on. So there's kind of, and then as we do hunting, this goes up and down. The CPU and memory goes up and down, so we were doing some hunting there. All right, so this is basically how to deploy it, get it going, and ready to go. And now we're just going to actually use it to investigate an endpoint. Okay, so to just kind of see what's going on with the particular endpoint, so interactively. All right, so this is the interactive part. So what we're going to do is search for clients, and there is a little search bar over there. And typically, I mean, if you just hit it, it just shows you like the first random 50. And so you can actually use your host name. So for example, this host name is called linux.conf.au. So it's got searching and all that sort of stuff. You can see the client ID. Make it a little bit bigger. Yeah. Client ID is just a hash, actually, of the public key of the client, so it's unique. And if you click on it, it collects some metadata about the client, but not very much. So it basically collects things like what's the version of Velociraptor, you know, what OS we're talking about, and the architecture. And that's actually all the information that we have to have about the endpoint. But if you click on VQL drill down, then you'll see that we actually have a lot more information here. And here we can see that there is memory and CPU footprint, and you know, we can do active users and all these things. So these are all just different queries, different VQL queries that we just collect from the clients as a way of just knowing general information about it.
So you would expect these tools to be running permanently, both the clients and the server?
Yeah.
As data collectors all the time?
Yeah. Yeah, and we'll see that basically that's the utility of it, is that you can set up queries that continuously run forever, and they specifically detect certain conditions to tell you about it. So this is the point. But for this part of the workshop, we're just going to interactively look at this client and just see what we can see about it. And so we can look at the VFS. So this is the searching part. And we can see the client version, client footprint. You can actually customize this and add other VQL to it. And we're not going to go into this in this workshop, but you can customize all the dashboards, basically. Yeah, client ID. And we can see the memory and CPU footprint. Now, this is really important because if you have this deployed, and a lot of users are tech savvy, and they're like, oh my God, your Velociraptor is using up too many cycles on our machine. It makes it slow, and they complain about it. And so it's really important that we collect telemetry of how our tool is impacting their performance on the endpoint. We want to be as light as possible. And so we collect a sample every 10 seconds of memory and CPU load on the endpoint. And so this is our telemetry. So we can go back in history and say, on this day, this is what we did. And actually, you can see that as we're doing like pretty heavy hunts, you can see that peaking and then going down and up and down. And so we can tell exactly when a hunt ran. We can show the user a graph of what actually we did on their endpoints. And you can see that typically, we're about the 30 megs footprint, and it's pretty small, and usually it's around the 0. Okay. Oh. So the next thing I wanted to show you is the virtual file system, and the virtual file system is just kind of a way that we visualize files on the endpoint, right? So we don't actually browse the endpoint interactively. What we do is we cache that information. So if you send a command to say, like, refresh this directory or get me the contents of that, so we cache that on the server so that you can see it later on. But it's not live in the sense that every time you click the button, it automatically goes and gets it from the endpoint, because the endpoint could be offline, and you might want to browse it later. So this is the virtual file system, and you can see that we have a number of different things. These are Windows specific, so they don't do anything on Linux. But the file, when we highlight file, you see that it says there's nothing there, and we can refresh it using the toolbar. So we actually can click this one. And as soon as we click this, it's basically sending a message to the endpoint to say, refresh that directory. And this is the root directory, so it just lists the directory. So now we've got data, right? And yeah, so we can just sort of navigate this, and again, we get data. So it's just, the important thing to realize, this is just a cache on the server of what's happening on the endpoint. And on Windows, we have registry, so we can see the registry, and the NTFS is, we have a raw NTFS parser, so we can see all like the low-level NTFS streams, ADS, these kind of things. But in this case, what we might want to do is we might want to actually just go and browse the user's home directory, and so we can see their files. And so I think we had the first exercise, to show how to download, let's say, the bash history. So you can see that we can't actually view anything here, so it's grayed out, because we don't actually have that file. We just listed it, so we know it's there, but we haven't collected it yet. So we need to click this collect from client to actually collect that file. And then we have a little floppy disk here that says that we have the file on the server, so we can actually download it and view it, and we basically know what it is. So we can look at it here. So the bash history is useful to be able to see what's happening. And a lot of the time in these kind of Linux-based investigations, the attacker would break in, and then they'll start doing their own thing, and then we'll be able to see what they're doing in the bash history, and we'll have to ask the admins, did you do that, or or did the attacker do that, and then we find out what they've been doing basically. Yeah, so this is kind of useful. So let's have a look at this exercise. Determine user activity. Now, sometimes an account gets compromised, usually through maybe SSH brute force or something like that. And then the attackers they get a shell, they go in, and they do stuff. And our job is to figure out what did they do, what was going on, what's the threat here. And so some of the things we might look at is maybe the bash history. If the attackers were sloppy, they might forget to delete it or wipe it. Less history is quite useful. If they use less, there's actually kind of a history there. And Vim history is really cool. I just wanted to show you that. But so if they use Vim or VI to edit anything, then there is this Vim history, Vim info. And if you download that, it actually has lots of cool stuff. And let me just zoom that up. So you can tell the search patterns, what they're searching for. You can tell, and these are timestamps. This is really important to be able to say, like if the attackers jump in, and you see in this case, we can see if they copy pasted stuff, then the last few ring buffers are actually fully in that file. That's really cool. And then and then you can see that these are file marks, which are basically positions in files that they edit. So every time they edit a file, it gets put in there with a timestamp. So it's really cool. We can say, this is me just setting this up, of course, so I added these things. But this kind of thing is really cool, right? You can see, they added authorized keys on this time. Why did they do that? Maybe they're adding another key there. This is actually quite useful. So you can see this file is actually really cool from a forensic perspective to try and understand what the bad guys did. Okay. So this is kind of fun, and you can see we can get like information there, timestamps and so on, and that's fine, and you can do that, right? But so let's give you guys a chance to do it. Is that right? You want to go? Yeah. Okay, is it actually on?
This connected, but
okay.
Doesn't seem to be.
So if you click on this
One?
Yep, and then have a look there, any of them. Yeah, and then click on the log. So it's trying to do the file listing. You just click on this. So it's actually sent it /home. Is it on a different partition or something, or on NFS or something like that? Does it have access to it? The client?
It's running as root, same machine. I used the deb for the client and the server.
But it refreshed this slash correctly, right?
Yeah. But it's not going with
Is there any other directory? What about other directories like Etsy? Does it do that?
no.
No. Oh, something happened there. All right, I'll just give you a couple of seconds to move through. It's just that. Yeah, so we could actually interactively inspect the machine. Sometimes that's the easiest way, is to just look at a file or two, but it's not really scalable, to do a proper investigation that way because it's just very tedious. What we actually want to do is automate everything and be able to extract the most relevant information quickly. So in reality, when we do investigations, we actually want to know high-level questions. Like remember when we talked about the vim info file, and I showed you all the interesting things in that file. I mean, it was kind of interesting to talk about it, but realistically, like who cares? At the end of the day, the question is, what did the attacker do between this time and that time? The attacker broke in at that time. Which files did they touch? What did they do? Where did they go, right? And so these are high-level questions, and the forensic information in the info file was, just the mechanics of how we answer those high-level questions, but we don't really necessarily care so much about that. We care about the questions. So this is kind of mental separation of concerns where we actually want to ask high-level questions, and the mechanics of how to answer that is the forensic knowledge of how do we actually, which artifacts do we look at, which files do we look at, to support our evidence. So the idea in Velociraptor was that how do we encode that expert information of knowing where to look, in order to try and help people answer those high-level questions, so that they don't need to be, experts about on all the low-level details, but they can actually be more guided by this. And so that's kind of the main goal of Velociraptor, is to sort of simplify the DFIR process and simplify the forensic process so you can ask those questions. And so what we actually do is we create this thing called an artifact. An artifact is a YAML file that kind of encapsulates a particular type of information, a particular artifact of information that means something, and we give it a bit of a human-readable meaning, and try and answer a question. And the actual mechanics of how do you collect this data, how do you interpret that data, that is all done through VQL, through the query. So let me just show you an example, and that's probably going to be the easiest thing to explain it. So let's look at the artifact that collects the authorized keys. So for those, I assume people know, there is a file, .ssh authorized keys, and if you put your key in there, your public key, then it will grant you access to the system, right? So you'll be able to log in with your private key, obviously. So it's a good way of basically allowing people to move between systems without having any sort of SSO infrastructure. And this is kind of like this ad hoc way of, it's very common among Linux machines to allow people, and even jobs, processes, to do that. A lot of those SSH keys belong to automated accounts that create different processes that need to automatically log in without a password. So this is kind of the idea. So what we want to do is maybe we want to collect all the keys across the entire network and ask the question of, like, who has access to which account if this key was compromised, where would they be able to go? Which access would they have, right, all around the network? And because it's ad hoc, essentially, if there is a server somewhere, it may be a cloud instance that no one really remembers about, and that key happens to be in that user account somewhere there, then that is a trust relationship, and suddenly that compromised key can go in there as well, right? So we just want to know that. And so this is a fairly typical kind of question that we have to ask. So let me just go over here in that little, you can actually open this up, the view artifacts. And if we just search for SSH, then you can see that there is a linux.ssh.authorized keys artifact. And that artifact is designed to collect all of the authorized keys. And so you can see that it has a bit of a description here, which is parse the SSH authorized keys files. It has a parameter which allows us to tweak where are we going to look for them. And then here we have some VQL. I'm not going to go too much into this VQL, but you can see that it's basically a query language. It's similar to SQL, except the major difference is that instead of selecting from tables, we select from plugins, which are essentially functions that we can pass parameters to. And this allows us to be very powerful and very expressive in the way that we do it, that we specify. So you can see that now as a user, I don't actually need to remember this VQL or even know anything about the format of an SSH authorized keys file or where I would be able to find them. I just need to collect this artifact and I'll just know about it, right? So let's do that. So let's do that as an exercise. Collect the user's authorized keys files. Okay, so first we would need to click collected artifacts and then collect more artifacts and then select it and add it. So I'll just do that. So over here, we can open this for the collected artifacts option. And we have to have a client selected to be able to see that option because it only operates on the client. And now we can see all the artifacts that we've collected. So actually, I did not say this before, but in Velociraptor, everything is an artifact. Okay? So before, when we were clicking around the file system, downloading a file and listing a directory, they're just artifacts like everything else, right? So now we can see this is a record of all the artifacts that we collected from this endpoint, including the listing of directories and all this sort of stuff. But now we're going to actually collect the artifact directly. So we click that little plus thing, and that gives us a search box. And again, we're going to search for SSH and grab our authorized keys, and then click Add over here. It's very important to click the adds because otherwise it's not going to do it. And you can see that it's actually added a new parameter, so I can tweak that artifact a little bit. If I wanted to look for authorized keys maybe in a different directory, then I could do that. This is just the default, and I think you can change it with configuration files and so on. But we're just going to collect it, and you can see that it basically, it's got this little hourglass thing, and let me just try to increase the font, so now it's a little bit harder. And so you can see the main screen here with the artifact collection. Over here, it's telling us how long it took. 1 second. This is the parameter. If we uploaded any files, it shows us here. This is actually what went to the endpoint. And then these are the results. So I'm just going to show you. Actually, before I show you the results, I'll show you the log. So when we run a query on the endpoint, we are running a VQL query. It logs things. Right? So as it goes along, if it has any errors, it tells us about it. It tells us some information. And you can see that it's telling us starting query execution. And then it says sending response 2 rows, 1.1K. So this is telling us this query that ran at time 0. It kind of rounds it down. It's completed, and it sent 2 rows. And so it's like, you can think about it, it's basically like querying a database, right? You're querying the database, it returned the query, and the result set came back, everybody's happy. So it's just, everything in Velociraptor is just a table, columns, rows, right? So it's a query. And this is what came back. So you can see now I have all the keys, authorized keys here, authorized keys there. So now, and in my case, I mean, your case will be different because you'll have different keys. But you can see if you have keys in there, if those keys become, they are actually the same, right? In this case, the actual key is the same. So that tells you that the same key is in two different user accounts, and that allows you to traverse from one user account to another user account, right? So if, because you just use that key, if you and this is what tends to happen in these kind of things, is that there would be a developer or something like that account that would be added as an authorized key to a service account. Let's say you have Jenkins, and it builds packages, and then it has a service account that goes and pushes to production, right? And then a developer account gets compromised, and then the bad guys, they jump from that to Jenkins and take the key from Jenkins, and now they're in production. This is kind of how it really works. So even if the developer didn't have access to productions, you can traverse that way, right? So this is kind of important to do these kind of investigations. But as far as Velociraptor is concerned, it just queried it, it brought it back, and all of it is implemented through VQL. All right, so this is basically what we did here. This is the artifact that we collected. We saw the results. And now, this is pretty good, but if you have many results here, it's probably not easy to read. What we actually want to do is we want to actually get the data. Right? So if we go over here, prepare a download, and it would actually create a zip file for us that we can download. Right? And it contains all the data. And the zip file is the ID of the flow ID here. So it's a random number. Okay. Now, I'll just show you how to open another terminal. So it's just a zip file. I'll make it a little bit bigger. Downloads f.bo. F9. Okay. All right, it's just a normal zip file, and it contains all of the results of this collection. Right, so some collections actually also collect files, binaries, any files that that you want, and some just collect CSV files for the query, right? And so we can get both with this zip file, both the actual file or the zip files. And sometimes we do collections and we have like 9 gigs of data in this zip file that we can grab. Okay. Yeah, so we've been through that, and it's just a normal zip file. This is a GUI zip program, but you can use. All right, so let's have a look at the scenario. So we get a call, an admin is leaving, okay, and they say, oh, Bob is our high-level access. He had a high level of access. He said he was leaving, and we don't know, whether there's any more access. How do we remove his access, right? Because, by the way, we don't even have SSO. We have no idea. He could have an authorized key somewhere. He could know a password for somewhere. Could he get back into the system? We just don't know, right? How would you solve this question? Suggestions?
Search EC password, see what his username, what servers his username has accounts on.
Okay, yeah, cool. So see which servers has his accounts of with his username. Yep.
Starting from his own personal PC at the business, you find that IP address and then go and find
That's a good one, right? Yeah, cool. So, try and look historically, where has he been logging into, because as we've seen before, you don't have to have the same username, right? Like if he had his key in the service account and then, like that kind of thing. Yeah? Yeah. Does any of the authorized key files contain his key? Yeah, that's a good one.
Is that SSH config file?
His own SSH config would have shortcuts to the different machines, right? Yep. Cool. So there's lots of ways, right? It's actually kind of cool. This is like when you start to do these. We've learned about tabletop exercises in an earlier talk. And this is kind of interesting. Like how do we answer these questions? And there's not really the right answer. There's all just, and none of them are perfect, right? Because, he could have had his own secret key. He could have had, that he added and you don't know about. Or, ideally you would have good key hygiene and you wouldn't have this problem. But, like in this case, they don't have it. So these are all just different artifacts. So it's kind of interesting. So let's look at the first example, which would be look at the machines that he'd logged into in the last 2 months, right? Let's see where has he ever logged into it, Well, we don't have centralized logging. We have some local logging, That's, I guess, the best we can do. So we might want to ask all our endpoints. We'll have a question like, tell me, who logged into this machine, right? And so we're just going to scan the SSH audit logs and do that. But it's not centralized, so we're going to have to kind of scan it like on the box. We could grab it, but we want to do it from 20,000 machines like at once, right? We don't want to log into 20,000. It's not scalable, right? So we want to actually automate all that. So here's what this particular SSH log file line looks like. This is what happens when you log into an SSH box. We get a log line and it says like the name of the box, dev box, and then it says accepted password for the user from an IP address and a port, and this is the protocol SSH2, and we want to parse it. So we could do like a regex, and like pull these things out. But in the industry, there is a standard called Grok. Grok is more of a for parsing syslog, and it's kind of a more structured way of doing regex. Have you guys ever heard of Grok? Has anyone? Yeah, a few people. So it's kind of useful to be able to support this more or less standard. And I just put it as an example here to show you what a Grok looks like. And the idea is to get a line from syslog and basically return a dict that has fields that are meaningful. And this is like converting unstructured syslog into a structured log, because then we can query it and do different things on it. So that's kind of the purpose of Grok, right? The Grok is essentially a regex with specification, and it's kind of recursive. So you could define things in a recursive way. So for instance, in this case, syslog timestamp is in itself it's an expression of a regex, right, which contains the Jan 5, the 0956, whatever. So this entire part will be parsed by timestamp as a timestamp, and then the colon means to call it timestamp as the field, and then comes the host, right? And then there's a program, which is SSHD, and oops, even I did it, ridiculous, and so on. So you can see that when we do that, it actually collects all of these fields into different fields. And then over here, if you can see the query, it's a bit small, but essentially we apply the Grok expression, and then we kind of pull it out. And then for each of those things, so we go off and find all the syslog files, and then we parse them all. So this is what this query does. All right, but anyway, we don't need to really necessarily care about what this query does. We could just simply collect it. Is that me again? it off. Okay, so it's the same mechanism, right? We just click plus. We say, what do we want? SSH. And we just want to get the SSH login messages, right? And so that looks pretty good. We click OK. And normally the default location of the auth logs is pretty good, and the timestamp. But if we have to tweak it for whatever reason, we can do that here. And off we go. And so what's going to happen now is we just launched a query on all our endpoints. They're just like little databases. And they go, oh, my God, we're going to query this thing. And the query is basically processing the syslog files. And then it's sending us a row per login attempt, right? So we can have accepted or failed. Yes?
We're running this against one host at the moment.
Yeah.
How do you run it against multiple hosts at the same time?
I will show you. Yeah, absolutely. So it's very easy. We'll go into that, right? But that's a very good question. So the idea is that at the end, it really doesn't matter, right? Because it's just a query, and you're just querying one host versus 20,000 hosts. At the end of the day, the hosts are doing all the work. They are doing all the heavy lifting. So each host is looking through its own auth logs and getting you these events, and maybe filtering for high-valued events or important ones, and then sending them back to the server. And the server, all it's doing is it's collecting these result sets and like just shoving them on disk. So that's how it's scalable, right? Because the server doesn't really do anything. It just, and it distributes the work to the endpoints. So you can see in this case, it took about 2 seconds. I'm looking at the start time minus the active time, so it's 2 seconds. These are the parameters and so on. If I look at the log, then it's telling me, progress as the query is running. It's saying, oh, it's sending, by default, it sends 1,000 rows at the time. And so it's doing it twice. And so we have several thousand ones. And then if we look at the results, we can see some interesting stuff, like we can see accepted. So it's interesting to see, like public key and password. That's cool because, does the user know, like Bob? We're going back to Bob, right? Does Bob know the password? Is it a password auth or a key auth, right? Like sometimes you have password auth equals no, right, in the config. Yeah, so that also is an auditing thing. Maybe your audit said, you should have password auth equals no, but then you can see in the log someone's logged in with password. Like, how does that work, right? So maybe it's a misconfiguration, right? That's a problem. And then of course, because it's a cloud instance, you've got all the usual brute forcing that's going on, right? And so on. I think there's all kinds of stuff here. Now you see that the UI is only showing us 500, right? 500 rows, because it's just the UI. It's just to show you, that's kind of what you got, right? But we're not really relying on that. We are relying on the data. In this case, we can see from the log that it's returning about 1,600 rows, right? So it's a lot more. So we should actually just grab it like this, prepare a zip, and then download it. Okay, and then we could have a look at this. BOF9A. Yeah, this one, right? So you can see that this is the syslog SSH logins, right? Now, it's just a CSV file, so you can sort of load it into, OpenOffice or LibreOffice or something like that. But it can be very large, right? It's a large CSV file, and so LibreOffice will probably die, and it's not really the right tool for it. And so a lot of people want to do some processing on this stuff. So JSON actually is more useful because you can use JQ or other tools. And so I've built some help into Velociraptor to help with that. So you can actually Velociraptor. If you go, there's a couple of utilities, unzip-l, which is just kind of the same thing as unzip-l, but it's basically running a query. Again, all of Velociraptor is just a query engine. So it's running a VQL query to list the zip file. And it's showing us, and we can actually do --csv and tell it to essentially dump out the CSV. Less. So it dumps it out. So essentially, it's just a CSV file with columns, but this is now in JSON format. And then we can actually apply filters on that as well. --where, because it's just VQL. So we might say where attempted user matches. This is the match operator. Mick, let's say. So it's just showing us, oh, well, I mean, it could be Bob, but there's no Bob here, but yeah. Now we're just going to look at, so we're just doing some filtering. So basically what this is doing is it's running a VQL on the zip file, which has the full result set. Now, normally you would, so you can do that. It's not too bad. And I've done it on gigabyte files. It takes a little bit longer. But if you're going to use it permanently, you might funnel that data to something like Elastic or MySQL or a different database. Then you can do a lot more queries. But if all you ever want to do is you just want to look at a small subset and then you don't care about the rest, it's kind of overwork. It's an overkill. This is probably fine. Because it would just take a long time to upload it first and then query it. Then you might as well just do it here.
Can you do the querying or a subset of the querying at the client so that
Yeah, absolutely.
you script it on the collection so that
Yeah.
you're actually doing partial data?
Yeah, absolutely, exactly. And this is what we want to do, right? We want to be more surgical. So you're leading me to my next slide. It's great. So so this is what we did, right? So I'm just covering off what we did. I'm just going to fly through these slides because we did them. So we can see some legitimate ones. We can see some brute force ones. And we can do offline analysis. So you notice that we don't actually build any indexes. We just give you the data, right? So you run the query. We get the result set. We put in a CSV file and just let you handle it, right? And so you can export it as a zip file, a JSON, CSV. But in reality, if you're going to do more querying, and a lot of people, that's what they do, is they forward that into Elasticsearch, Kibana, and they put dashboards and all kinds of stuff. And if you want to do that, that's really great. So that works. This is how you do it. And these are just the little utilities that come with it that just converted from CSV to JSON, and then you can add a filter. So this literally just builds a VQL select, blah, star from, parse CSV where, attempted. This is actually just literally does that. Yeah, this is what we're doing. Okay, so let me just talk about the hunting, and then we'll talk about the customizing. We don't have much time. So hunting. So hunting is actually all about searching for this thing across the entire enterprise, right? And so we want to actually just issue that query across everything. So really, it's a very simple concept. We have a query. It collects specific information. And the query can be very specific. So it can actually be so specific that if it returns any rows, that's bad, right? Like if you say, for instance, if we have, let's say we have a private network, and if we say, let's write a query, if we have an accepted SSH connection from the internet, terrible, bad, it should not happen. Like it might be in your environment, that might be a really strong signal, right? And so you might say, well, I want to do this across the entire network. If I even get one result, hit the alarm button, right? That's really bad. So this is where hunting can become detection, right? It doesn't have to be. It can just be also, I just want to get this information and I can just chop it up later and post-process it and get stats and work on it. Or it can just be detection as well. So this is kind of why we would do hunting. But actually, it's just as easy. It's the same thing. All we do is, I'll just open this, Hunt Manager. We click on the Hunt Manager. And here we see all the hunts. So let's do that again. Let's get the authorized keys again. So it's the same thing, right? You see it's the same GUI even. we click Add, we can hunt for multiple things at the same time. Same thing, we may customize it, and we click Next. We have the description. So this is where we get to write like maybe a ticket number or a particular authorized keys hunt for Bob, you know, something like that. We can put a client limit here and that it will pause, but you know, I don't think I ever use that because it's pretty fast already. And you can put conditions here, and conditions are like matched by label. We haven't talked about labels, but you can label machines into groups and so on, or S's, particular operating systems, or whatever. And you can see that that created a hunt. So the hunt is in the paused state, as you can see. And this is coming from, so Velociraptor is coming from an idea of GER. GER is a previous tool by Google to do similar thing. And when you're in a very large network and you're about to run a query that might destroy machines, right? then the workflow is very cautious, right? It's like, okay, we're gonna start the hunt. It's gonna be paused, and you have to actually click the button and say go, right, before before we do this thing. Yeah. So we have to go through that extra step, run this hunt, and proceed. And at that point, the hunt becomes running. Running is that icon there, and you can see that as soon as you hit, as soon as you hit that button, then all the clients that are currently connected, they just get scheduled. They just go, right? And so you can see here there's the total scheduled and finished. So they actually off we go. And I mean, this is a very quick one, so they finish pretty much straight away. Now, this is still running. So if I go and, you know, like make another machine, and if we put Velociraptor in the SOE, then it will just start up, right? Or so, you know, a new machine comes online, whatever, then it gets the hunt and it gets scheduled as it comes along, right? Yeah, so that's basically the idea. So these are all the clients that have been scheduled, and these are the results, which are essentially the combined results of all the clients in one, you know, big CSV file, right? And if we go over here, same kind of idea. We click the download, and it will make up a zip file. But the only difference is that now the zip file starts with H because it's a hunt. And H dot, yep. And you can see that, and now what it does is it actually it collects the results from all the clients like separately, and then it makes one big CSV file of like a, you know, combined of everything. So if we had multiple clients, then it would all be different under the different client ID. But usually we just really care about this one. And it's just a big CSV file. So, you know, we could -CSV. So we can get, you know, all the keys, right? In a big JSON document, it's just a big thing. And then you know, you can do things like, you know, group by or whatever. Like you can use JQ or even just grep to see if a particular key signature exists in this hunt, right? And this is where we're going back to that question of, you know, did Bob have his key, you know, somewhere, right? Yeah, just make sure that I covered this. Okay, cool. Yeah, we've been through that. And you can also do where key equals. So I've already shown that. So again, the same kind of idea, right? Where the key is matching a particular thing. So this goes to hunting, right? And as far as performance is concerned, it's actually really, really efficient because it's the endpoints that are doing all the actual looking, right? And then they're sending the result to the server. The server just drops it, you know, in a disk, right? So it doesn't really do a lot. It doesn't really maintain indexes or anything. And then the next topic is surgical collection of evidence. This goes back to your point of saying, well, I actually only really care about Bob. I can either process that data, or I can just look for Bob, right, in the first place, right? So this becomes the more surgical thing. So so this is where we want, trying to keep one step ahead. And if you're doing the FIR, it's just a never-ending, game, right? Like you keep reading posts, blog posts, and they say, oh, we found this new APT group or new group that are doing these. They use this kind of malware. They might use this kind of technique. They're doing all these things. These are all the indicators. So you've got to keep up with the activity of the bad guys, how they're going. So basically. So you have to learn about what they're doing. So ultimately, what we really want to do is we want to know when the endpoint's compromised, right? So we have to keep coming up with ideas of how to detect that, how to detect those techniques that the bad guys are using. And so I just have a couple of examples here. I'm just going to run through them a bit quicker. This is the attack network, MITRE attack framework, which is a well-known attempt to catalog all the advanced attackers' techniques in a way that you can actually almost tick off. Do we cover SSH vulnerabilities? How do we? So you can actually look at that attack matrix and actually come up with mitigations for each of those things and try and think about how am I going to detect these particular techniques against my infrastructure. So I'm just going to give a couple of examples. So the first example, I just picked these in random, actually, and it's kind of a lot of fun to just go through them and learn about what's going on in the world of bad guys, attackers. So the first one is private keys. So it turns out that, we talked about public keys, and they give you access to SSH. It turns out that your private key can be either encrypted or not encrypted. And typically, people make unencrypted private keys for automated logins without a password, but that's not great to do that. And so typically, you should encrypt your private key. It means that you at least need a password to unlock it. So if someone breaks into your machine, they grab your ID RSA private key, then they don't just immediately be able to use it, right? They have to at least guess your password. So it makes it a little bit harder. And it turns out that you can tell whether a particular private key is encrypted because it tells you in the file. Like, so you see the heading is like begin RSA private key, and then you will see, this kind of, the word encrypted, and that means it's encrypted, right? So we can immediately think, oh, well, that's a well-known threat in the attack matrix. How do we actually check for it, right? Like, let's do that. Let's check all our, enterprise for anyone that's having these private keys, unencrypted. Then we can send them an email and say, hey, just don't do that, right? So we can just write a VQL query for it. So you can see that this is a very simple query. We do a glob for all of these things, ID, RSA, and DSA. So this is like a glob expression. It's just like a shell, basically. And this is a VQL plugin, and it will return a row for each file that it matches, right? And it will have a full path. So we're going to return that. We're going to return the timestamp of when that file was modified, so we know when the key was created. And then we have an if statement even. And then we can run Yara, which is, Yara is basically a grep, a very fast grep. It finds keywords. We're going to look for a wide or ASCII, so it can be either wide or ASCII. I have no idea if it can be wide. Wide is like UTF-16. I'm not sure if you can do that, but anyway, we're covering off just in case. If we see the word encrypted in it, then we say yes. Otherwise, we say no, right? So that's our query. Okay, so it's very straightforward. So let's do that real quick. So we go back to our guy here. And okay, and then we have our private key artifact. And again, the whole point of this is that we are translating this knowledge of what exactly are encrypted private keys and how do you determine this into an artifact. So the user doesn't really need to worry about it. And we just look at that, right? So this is the type of thing that we get. So you see the user Mick. has an SSH key, and yes, that's encrypted, so that's good, right? And then this other user does not have an encrypted SSH key, so it's no, right? So that is, you know, something that we might want to remediate, right? So immediately, now you can see that the process that we've gone through is, you know, there was attack framework, and the attack framework said, this is what the attackers are taking advantage of right now. This is the intel that we're getting, and these are the vulnerabilities. And now we wrote our own artifact to say, let's look for that, and then we're looking for that, and then we're covering off our bases. Now we can say, against this one attack thing, yep, you know, we're good, right? So we can secure ourselves. So that's the process. That's the DFIR process. The next one is setUID, setGID. And you guys can copy paste it. So this is basically an SUID root shell. So it's if you create, let's do it at /temp. Okay, so you basically create a small program, int main, set resuid 0, and then bin shell. That's actually a backdoor, right? You create a backdoor. Oh, I need to be root. Sudo bash. Sorry. Okay. And then you see immediately that it created a binary. It's very small with, you see that S here, that's SUID. And so I am now a user, just a normal user. And if I run it, I get a root shell, right? So this kind of thing is just a very standard Unix backdoor, right? But it's like kind of, now the question is, attacker went through, they compromised the system, and they're just dropping a binary somewhere, right? Maybe this could be in a CGI bin directory, for instance, and then they come in with CGI request, and they can do stuff as root of the web, or all kinds of stuff, right? And so the question is, you know, which SUID, you know, binaries exist on this machine, right? Running out of time. Yeah. So you know, we might say, well, let's go and find it, right? Let's globe all the files in our directory and find the SUID one. So we can run a VQL query to do that. Let's have a look. So here, let's search for SUID. Okay, and we find, you know, in Velociraptor's, you know, library of artifacts, we find this we're going till 310, really? Is it 310 or 3? 310. Oh, cool. Another 5 minutes. So again, the same thing. So basically, it's just a big glob. We start off with a default glob expression, like maybe /user. If it's a big system, it's going to take, you know, a lot. So we might not want to do // but, you know, we might want to look everywhere as well. And, you know, we basically just filter out all the files except the ones that have this mode UID, right? So let's do that. This is going to take a little bit longer. And you can see this could be a little bit heavier because it kind of, it's just like doing a big find, right, on our system. Okay, and then again, we can do that as a hunt. You know, all our 20,000 machines are going to be looking for this thing and coming back. And it's actually not a lot of data because, you know, maybe you expect, you know, 50 different SUID program on your system, you know. So it's going to be 50 rows per system, you know. I don't know, it might be 20 meg CSV file or something. It's not a big deal, right? It's actually, the numbers these days, machines are so fast and they have so much RAM that, you know, it's just not a big deal. Yeah, so you see it's gone off. If we look at the log, it says it's returned 13 rows. If we look at the results, we can see all the SUID binaries on this machine. Yeah. Oh, okay, so it's only looked at /user now because that's the default. Actually, I put it in temp, so I will actually try and, this time I will modify the default. I forgot to do that. Star is recursive search. So it's an extra star. It's better. Yeah. So now it's searching over the entire, file system a little bit more. So it will take a little bit longer.
If that's set as a hunt, does it periodically trigger?
No, it just runs and completes. Yeah.
It doesn't run again.
No. But we'll go into that. Yeah. Okay, great. So so we should be able to see, the one at /temp. Yeah, here we go. That's our private shell, right, that we created. And you're like, oh, what is this, right? So now, if you were to run this, and you'll be looking at all these other ones, and /temp /private shell, it's pretty obvious, right? So, but the bad guys aren't going to be that nice. They might actually hide, maybe /binps, or might call the program something else. So it's kind of hard to tell that it's out of place. And so you might want to actually look at hashes and try and actually, get more certain about it. So in this case, this artifact doesn't give you a hash. It just lists the directories. So what we're going to do is we're going to customize it. All right, we're going to say, well, let's custom. I also want the hash because, so we go over here. We find the SURD one over here. And we click this button, and that brings up an editor. Because again, an artifact is just a YAML file, right? So it creates a customized version. It makes it custom dot whatever. And then we go down to the query, and then we might add another column. And in this column, we just go, okay, hash, okay, path equals full path as hash. Again, it's just like SQL. So there's a hash function, and we just say, oh, when for each of those rows, just do the hash, right? So we now get an extra, and this is called enrichment. We are adding information to something, right? So we're enriching it. So so we don't change anything else. And now when we do it, we still have the old one, and you can notice that we still can do the old one. We're not overriding the old one. We're just customizing, with a new one. And do that. Okay, and then hopefully it's going to also add the hashes. Right? So it's already sent some rows, and you can see that over here it's done some hashes, MD5, SHA-256, whatever. So we can see that we can customize that very easily, right? We just basically, it's just a query. We just call the query. We add a few things. And once you actually feel comfortable with VQL, you can write your own. But a lot of the time, you just want to tweak something, add another piece of information or whatever. Okay, so we've done that. We found the shell, customized it, modified it, and we could take the hash. Maybe we could put it in varstotal. We clicked the button. We looked at the editor, and we added the hash, right? And then we changed this thing, and now we've got a hash. So we move closer. Okay, the next cool thing, process injection. Maybe we'll skip that. I don't know. It's basically an LD preload kind of backdoor. I'll just say it. Yeah, so we can find it, but it's just basically a preload. Oh, we might do it. Oh. Yeah, I mean this is sysmaps. So you can sometimes see with an LD preload type of injection, process injection, you can see an extra library loaded in the processes maps. So we can actually look for that. But yeah, let's move on because we don't have a huge amount of time. Chrome extensions. Now that is actually a really cool one. So Chrome extensions actually can be very dangerous because you know what? These days, if it's a user desktop, the attackers, they don't care about being root. They don't care, right? On the server for sure, but on the user, they're not actually interested in being root. They want your banking details. They want your cookies, actually. So because everything's happening on the browser, they just want to be able to compromise your browser. And a lot of the time, they can do that by using Chrome extensions. And the Chrome extensions actually have a lot of power. And some of them, can do things like they listen on the microphone, they turn the video on, and things like that. So when you have an enterprise with lots of users, and maybe some of them are not well educated in, Chrome extension, security, then you could have some odd things being installed. So this is one of the most interesting ones. It's basically just kind of collecting all the Chrome extension. And it's actually pretty easy to do because we just run a query. And it is actually one of the more complex queries. It goes over several pages. But as a user, you don't really need to care too much about it. You just run it, right? And it's actually very, very quick to do. And it's one of those things that you can hunt over the entire infrastructure. And you can see there's kind of an interesting thing that you can do with that because you can see which extensions, Chrome extensions that people have that are not very common, or you can see ones that are actually quite powerful. Over here, if you scroll to the right, you can see that this is a list of the permissions that this extension has. And some of the permissions are pretty extensive. You can see that some of them have network access and video access and media access. And you see the capture and web view and all this stuff. And so, some of them are, legitimate. Like the Zoom extension, for instance. Zoom is like a meeting kind of tool. It has desktop capture, so they can actually capture the desktop. And they can actually do video capture and all this kind of stuff. So it's actually pretty extensive. So as an admin, you can audit your network because this is actually a good way of exfiltrating stuff or, basically just general audit. Yeah, so suspicious extensions with unusual things. And then if you found a couple of suspicious extensions, then you can just upload them. So I haven't shown too much how you can just grab files as well. I mean, we grab files with the VFS, but also the artifacts can just grab a bunch of files. And so you can actually use this other one, Linux application Chrome extension upload, and it will just grab like all of it, right? But it can be quite large. So I'm just going to show you what happened on my other box when I did this. So I ran this thing, and then it failed. Failed means that it had an exclamation mark, an error. And then the error was query timed out after 600 seconds. And this happens sometimes. And you can see that it's transferred almost for 400 megs, 390, with 2.3 thousand files before it timed out. And this happens a lot for us because I mentioned before that we are very careful about Velociraptor, and the problem is that you can inadvertently, explode the thing, right? Like you can do a query that's a lot more expensive than what you anticipated, right? Like you might think, oh, I'm just going to grab my Chrome extensions, just upload all the files, and it turns out there's like 50 gigs of stuff in there that you just didn't know about or didn't expect. So that's why we have these kind of mechanisms in the endpoint to kind of protect us from accidents. And one of the mechanisms is there's a timeout on the query. And so the VQL query runs, and by default, it's 600 seconds is the timeout, and it will just time out and cancel. This is one of the things with VQL, it can cancel the query, and you can just cancel it at any time as well. But it's cancelable, it's asynchronous and cancelable and all this sort of stuff. So by default, it's 600 seconds and then it just times out. So it didn't grab all the files because it took too long in this case. And you can see in the logs, it basically goes through, it says, I'm uploading this part of the response, this part of the response, and then it just times out and then the whole thing cancels. And it's a way of us just kind of returning sanity to the endpoint so it doesn't go like crazy. Right? So resource management is actually quite interesting. And the other thing that we can do is we can rate limit on the endpoint. So if we are looking for something and our CPU usage goes up, let's say we are scanning for keywords and opening lots of files and doing that sort of stuff, it might impact performance, and we might say, look, we're going to run it against the server is busy, we don't want to impact performance, and we want to do it slowly. So we can rate limit, we can say, ops per second, 20 ops per second, and reduce that. And this is where we do that in the UI. Okay, I just want to very quickly cover this last part, which I think is the most exciting thing. Okay, so event monitoring. So I said that VQL is a query language, and imagine if you've ever used MySQL and you use the client, and then you send a query to the client, and then it basically returns a table with results, right? Now, if you've ever done a really, really expensive query that takes forever, right? And the thing is doing joins and whatever, then it will just sit there and wait, and then it will get all the results and just shove it at you, right? And you might have to wait a long time. It might time out as well. So VQL isn't quite like that because it doesn't really have indexes and things like that. What it does is it actually returns you rows as it processes them, right? So it's asynchronous, right? So you do a query, and it goes through, and it gets rows, and then it basically returns it to you as it sees it, right? So you can use that. Then I had this idea of like, why don't we use that to just say, well, each row is like an event. Then we can have the query never terminate. So it never terminates. It just runs forever, and it's just going to watch things for things to happen, for events. And then every time an event happens, it basically just returns that. And because VQL can use other queries as arguments to other things, so we can actually post-process all of that stuff in VQL, and we return it. So here's a VQL plugin that is an event plugin, and it might return events in random order. And then the query might take those and then group them together and then send them back to the server in batches, right? And so each of those result sets are going to contain the events. And it becomes then a monitoring tool, right? So there was a question before of like, if we look for a SUOD thing, does it continually tell us about it? Well, it doesn't normally, but if you do an event thing to say like, now watch this event, then it will do that, right? It basically just watches it continuously. So let's have a look at, so we already saw this before. We talked about a telemetry, and we said that, if we go over here, we've looked at the client telemetry. And I said that it returns, we basically collect our memory footprint and CPU load every 10 seconds. And so that is actually an event query, right? We are just running a query on the endpoint that never terminates and just keeps returning the events every 10 seconds of our footprint. And this is just, and we just store it on the server. That's just another kind of query. So there's actually no difference at all between this kind of query and any other query. So here's this example. We want to monitor the endpoints for successful SSH connections. So we already learned how to parse the SSH connections, right, from the syslog. But let's say that if someone was to break in and log into an SSH connection, we've got 2 minutes, then we can get an event from that. So this query is watch syslog, and it basically does exactly that. It watches the syslog file, and it parses it, and then it sends the results back as an event query. And I wonder whether we actually have that enabled. Maybe we do. Yeah, so this is the type of thing that happens, right? So you can see that so you click on this button here, and you add that artifact, SSH login. So it's the same kind of thing, but it's going into a different table. And then it basically will sync the endpoint, and the endpoint will start running this query as an event query. and then it just streams the results. And every time someone logs in, then I wouldn't say immediately, but because it batches it, but within a few minutes, then you'll end up with an event come up, basically being forwarded to the server continuously, right? So now you basically, if the attacker goes and wipes your logs, well, it doesn't matter. We still have it in the server, right? So we actually, it's a better way. Yeah. So this is actually kind of an interesting one, and the last thing that I wanted to show is process execution logs, because that is a very common thing to want to use. Process execution. And process execution logs is basically just a log of all the processes that are executing, right? And so you can tell some interesting stuff with that. And there's some post-processing that can be done, like, like Apache is spawning a shell bash, and then, spawning ls, right? Like, that's weird, right? Like that kind of thing. And so you can see that, and we can collect that with auditd. And if you've ever used auditd, you can realize that it's a real pain to use, because the syslog format is very annoying because it splits it across multiple lines, and it's really hard. And Velociraptor will be able to actually can watch the auditd log and convert it into normal processes, so we can do that. But that's the kind of thing that we do here for event logging. And then we can forward it to Seam or Elasticsearch or whatever. All right, so let's just wrap it up. So apply what you learn. Ask high-level questions. Dig deeper. And this was an introductory level workshop. And it really just comes from the VQL that we can write these different VQL, and you can really customize what you're looking for. And if you want to write your own queries, and you can also integrate with the APIs, and you can really build on that platform. You can build like a really solid detection and response things. We have some docs in the site, and we can also do other training. And this is our GitHub repository, and yeah, Discord and so forth. So yeah, if you have any questions, catch me later. I guess we're out of time.
Thank you, Mike. I'm going to give you a small token of our
Oh.
appreciation.
Thank you.
Thank you. I learned a lot from that. You'll be around in the break, I guess,
Yeah,
if people want to
absolutely.
ask you some questions.
Yeah.
And you're in Brisbane as well, right? So
I'm actually on the Gold Coast, but
Gold Coast,
yeah,
so
Brisbane,
you're
Gold Coast,
local,
same thing.
so that's great.
Yeah,
So we can find you on your Twitter or LinkedIn?
Well, we have Discord,
Cool.
and so there's a Discord channel. A lot of people ask questions, and we have discussions. It's like IOC, but it's the new IOC, I guess.
Fantastic. Thank you.
Thanks.